Hi guys, today we're doing isomorphic strings. So given two strings s and t, they want us to determine if they are isomorphic. They tell us two strings s and t are isomorphic if the characters in s can be replaced to get t. All occurrences of a character must be replaced with another character while preserving the order of characters. No two characters may map to the same character, but a character may map to itself. So basically we're just checking to see if each character in one string maps to a character in another string and they're in the same order. So like in example 1, given these two input strings, we would output true because the strings can be made identical by mapping E to A and G to D. And then they're the same, right? Like if we were to replace this with the characters in this, then like as they're mapped, then they would be the same. In example 2, we would output false because it's not possible, because like we could map F to B, but then O would have to map to A and R for it to work, and we can't map it to more than one character, so this doesn't work. So then we would return false here. And then in example 3, we would output true because if we map P to T and then A to I, and then P is already mapped to T, so that's fine, and then E to L, and then R to E, then this would work, so we would output true. So we can basically just map our characters from one string to the other string, just like how we're doing here, right? So we can like loop through the strings and then map each character to another character as we are going through, like from one index, like from the same index, right? So like both of the ones from index 0 are mapped to each other, all the ones from index 1 are mapped to each other, and like so on, right? And then if we already have a character in our map that we just got to, then we just need to check that it's consistent with whatever it was mapped to before. So like in this example, right, if we start with P, maybe the first time, right, we didn't have P in there, so we add it, and then we mapped it to T, and then later we get to another P, and then we realize we already have P in there, so we'll just do a quick check to see if it still maps to T, and if it does, then we're good, but if not, then we know we'll have to return false at that point. So let's get started. We'll start by initializing our map. So we'll say map, and we're mapping character to character. And then we'll just say we're mapping the characters from S to T. And then we're going to want to start our loop. So for I is 0, I is less than, and I'll just say s dot length, but it shouldn't matter because they're the same length. I plus plus. Yeah, they tell us that t dot length is always going to equal s dot length, so we don't really need to worry about that. Okay, and then so we start at index 0. Let's use this example because it's a little bit more interesting. Okay, and then our map. Okay, so we start from 0. Our characters at index 0 is going to be P from S and T from T. So first we're going to check if our map already contains this key or not. So if map.contains key, and we're mapping S to T, the characters from S to T. So s.char at I. Then okay, so this is our first check, if it already contains it. In this case, it does not, right? So right now it doesn't, so we'll just move on for now, and then we'll come back to that. So else, so it does not contain that key. Then what do we want to do? Well, we're going to want to add that key. So we'll say map.put s.char at I with t.char at I. So in this case, we are going to map S to T like that. Which is what we're doing here. And then that looks good, so we'll just move on to the next one. So then I will be 1. So at I equals 1, we have A and I. So at this index, well, we still don't have A as a key, so we'll just add that as a key. So we'll add A mapped to I. Okay, and then I will be 2 at index 2. Well, s.char at I is going to be P again. So we're going to check if it already contains this key, and it does. So now we're going to need to do a check, right, to make sure that this letter is the same as what it's mapped to in the map. So we'll check if map.get s.char at I is not equal to t.char at I, then return false, right? Like, because we need to check that it's the same. So in this case it is, so we're good. And then we'll keep going. So I will be 3. And then, and then, wait, this was supposed to be a P, not a T. I mean, not a S or whatever I put. Okay, so anyways, then E will map to L, and then R will map to E. So that's what our map will look like in the end, which is consistent. And then here, when we check to make sure like that we want to add this key in here, actually, we also need to check that T is not already in our map. Because if S is actually, if the character at S is not in the map, but the one at T is, then we're still gonna have an issue. So let's just add a quick check for that as well. So if map.contains value, and we don't need to check for the key anymore because it's already up here. So in this else, we're assuming it does not have this key, but it does. We'll check if it does contain the value. So t.char at I, then we still need to return false because that's inconsistent. So yeah, I think now it looks good. At the end, we'll just return true if we could get through both strings without any issues, and that should be it. So let's run this. Okay. Time complexity. Let's see. So we just have this one loop here that loops through the length of the strings, which are the same. So we can say O of n, where n is length of input strings. And it doesn't matter which one because, again, they're the same. And then space complexity, we just have this one map that, worst case, if every single character in each string is unique, then it'll store each character in the strings. So the space complexity is just going to be the same. So that's it for this problem. Thank you guys for watching, and I'll see you guys next time. Bye!